Hello guys, welcome to Solving Solutions, your number one channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you how to use Python to calculate the distance and bearing between 2 points. So we have point A and point B here, and then we have their distance and their bearing, right? Good. So we want to use Python to do the same stuff. So when you open the IDLE, you can decide to create a new file so that you can start typing your codes, right? Good. So we already have created the code we need. Good. So we are on the Python folder. We have distance and bearing, and then we have the solving solutions code, right? So this is the code we are going to use: distance and bearing between 2 points. Now the first thing is that you import math. Now this import math helps you to import all the math functions that are in the math module. Then the next thing is that we declare the variables. We said we are using 2 points. Let's say A and B, right? Good. So we have *1, *2, not in 1 and not in 2, right? Then we are using float to impute the *1. This is because the *1 will be a decimal number, or it's a decimal number. So if we say integer, it will just mean we are saying 100 without decimal. So if we want to include 100.231, we definitely need what? Float, right? Good. So that's why you see float into a bracket of impute. And then what are we trying to impute? It will now print the what? The *1 is, right? Good. So similar stuff for the second variable, which will now store what? *2. Then the third, which will now store *1, and then the fourth, which will now store what? *2, right? Good. So they are all float data type or floating data type because they are decimal numbers. Now the next part of it is that we need change in * and change in nothings, right? Good. So simply change in * we use DE for change in * and then DN for change in nothings, right? Now this first line is for commenting, right? Good. So when you see this sign and then you see any other description with it, it shows that you are trying to describe what your program does. So Python does not run this particular line. So if I come down here and I still say it does not alter the progress of the program, right? Good. So this helps to describe, they call it commenting. This helps to describe whatever you are trying to achieve. So when you comment this way, Python does not run the comment. So the second one is delta nothings, which is change in nothings, right? Good. So the next part of it is that we need to calculate distance, and normally your distance is equal to the square root of your delta nothing squared plus your delta st squared. Now in Python, when you want to do exponentiation, that's you want to do raised to power something, you use double star. This is just like multiplication, right? Good. Maybe when you want to do d times 2 or maybe de times 2. So instead of having it as de times 2, we have de times 2. So this double star is exponentiation. So it means de raised to power 2 plus dn raised to power 2. And then your de is *2 minus *1, and your dn is *2 minus *1. So now this math.square root is actually part of the math function that we have imported by using this first line, import math. So if we had not imported math, we can't use this math.square root. So this gives you the square root of whatever you have in this bracket. Then the next thing is that just like we also have similar stuff in Excel, when you are trying to return the bearings or maybe angular values, you have it in radians, right? Good. So we have declared a variable and we called it bearings underscore radians equal to math.arctan2. Now your bearing is simply tan inverse of * over nothings, right? Good. That's delta * which is this value over delta nothings. However, the quadrants are different, and because of the different quadrants from 1 to 4, there are different operations that usually happens to the bearings, right? Good. So if you want the program to cater for the change in signs and then return your bearing as it's supposed to be, then you use this arctan function. It's also similar in Excel, because if you just use * over nothing, then you should be able to always satisfy the conditions for the different quadrants. But if you use this arctan2, it understands the quadrant where your input data falls, and then it gives you the bearing accordingly. Then after the bearings in radians has been returned, we now convert that bearings in radians, which is this one, to degrees. You know, we are trying to link it to Excel because we have similar video in Excel where we have used Excel to calculate the distance and bearing between 2 points, right? Good. So this math.degrees helps you to convert a particular value in radians to degrees. Even on Excel, if you have a trigonometric function and then you want to have its equivalent in degrees, the first native response or the native output is in radians. So if you want to convert that native output to the degrees, you now use degrees into that particular cell, and then it converts that value to its equivalent in degrees. So similar stuff we have here, math.degrees. Then what are we converting? We are converting this our bearings in radians, which is the line preceding this line. Are we together? Which is what? This line. This line stores our bearings in radians, and then this line now converts these bearings in radians, which is this, to degree using what? Math.degree. Now, why we had to put this conditional statement is that this arctan2 sometimes can return angles that are negative, and we know that there are no negative angles. So what we are saying is that if the bearings in degrees, which is our last term bearing, which we are going to use, is less than 0, you know, anything less than 0 is definitely negative, then we now have to add 360 to that value, right? Good. So that's what this particular line entails. So if maybe it does the computation and then you have minus 100, which is not feasible, you now say the program will now add 360 to it to give you its direct equivalent in bearing, right? Good. Then the last part is the print. We want to output whatever we have imputed, right? Good. So the first thing is that we are going to print distance just like we have the easting is. So we are going to print, and then we have a header for the distance, and then we are rounding it to 3 decimal places, which is what? Round into the distance, which is what? This okay, this is our distance. Now Python is case sensitive. You see this dist here. If peradventure I change the case of our d maybe to capital letter, there will be a problem. So whenever you're running your program on Python, ensure that you are consistent with your casing. Right, good. So you see this DE, that's the delta easting. If I change this D to small letter d, when I want to recall it, it will not see it as capital letter D. So ensure that you are consistent with your casing. So we now have rounding this our distance, which is this, to 3 decimal places, comma. We also want to add the unit, and the unit is what? Meters. Then finally, we also want to print bearing. We just want to have this as maybe the header or something. Then we are rounding our bearings, which is the bearings in degrees that would be following this particular condition if it's negative, right? Good. To also 3 decimal places, and then we also want to add the units degrees, right? Good. So if you have been able to, let's say when you have been able to write the program like this, you save. So we have Control S, rather I did Control A. So we have Control S. When you're done with that, you now run. Click on run, and then you run the model. Okay, so now the easting one is what? So what we are going to do is that we are working with these values. So you hit enter, it prompts you to add easting 2. Then we need nothings 1 now, right? And then for nothings 2, we have 535.128.921. So these are the values that we want to store in our variables. What we now need to do is to press enter, and then we have our result. So you can see the distance is 19.54. We have 19.54, and then the bearing here is 18.775. So if we bring in a calculator and then we type 18.775, then we try to get its equivalent, you have 1846.21. We have 1846.30, perhaps because of the rounding up to 3 decimal places. So we have shown you using Python how you can calculate the distance and bearing between 2 points. So we will definitely improve on this so that it will be more interactive, maybe trying to get a GUI or something. But basically, this is just the first of many to come on the channel. So ensure you subscribe to the channel, and then we are going to see you on the subsequent tutorials. Have a very good time. Bye.